Oh, there it is. Okay. Okay, give me a second to get it here. Okay. There it is. All right. Okay, let's see. Hello. Okay, if I can't shrink that down, have to use that. Have to go over here. Go to this. Okay. What the heck? Okay, where's my... That is weird. There's no... Oh, here we go. Alright, new page. New page. We don't need that. Put that on there. Okay, back to the full deal. Let's go now to here. Okay. Okay, log in. Okay. Okay. Fall. For some reason, we're at the bottom. Okay, content. Oh, I'm in content. What am I thinking? Okay, can't remember which week problem I was working on. So I'll just go to it and see what. I hadn't done that one yet, so let me go back a page. Okay, that was 5, so let me go to 4. I might have completed 4. I don't know. I did that one, and I think I did that one on Friday, but I didn't do these 3. I'll go in reverse fashion. I'll do that one. I don't think I did that one, but wait a minute. That is actually done already. If you go, yeah, so if you look, that one's done already. So that one's done already. That one was one of the ones in the example. That one, okay, I wish I had 2 screens, but that is the one with the, not that one. So that one's already done. It's already on one of the videos. I know if I go down, that one is the one up there. Did I do? It looks like I just carried on with that one. That's the same as that one. Okay, so which part of the, are you getting, you're getting the whole screen. Okay, so here I got part of the screen. There I got the whole screen. I don't understand why it's doing this particular way. I don't know. Let's go ahead and do this one. Let's, as long as I can get, okay. The window, let's see, I'll tell you what, let me zoom in on it. Get as good of a picture out of it as I can. Okay, let me try that again. I was about to say, do I need to try it a 3rd time? Yeah, I just copied the clipboard. I could just paste it there, but okay, there it is. Then we go back here and it says the window is held open by the chain from A to B. Determine the length of the chain. And it says the thing is 50 pounds. Okay, so, and express the 50-pound force acting at A, at the edge of that door, excuse me, along the chain as a Cartesian vector. Determine its coordinate direction angles. So, you know what? Since the text is there, I'll just grab it. And then that way I don't have to go back and forth between those two. And let me see. Make sure. Okay, so if I hit the Alt, I need to. Okay, I'll stay in the draw. Okay, Alt. Okay, so that brings me up. As long as I can, let me orient my body here and start working on this thing. So the first thing I need to do is determine the vector that goes from A to B. Well, let's see. I can do a Control C. Okay. So I'm going from A to B. My handwriting's not that good, so there. So there's A to B. So I got an issue here. He has made it particularly obnoxious for me to find some information here. So what I'm going to do is I'm going to do this here. If I put my hand here, does this work? Okay. So what I'm going to do, I'm going to try to find this vector, r sub a. Then, that didn't work out right. But anyway, that's a straight line right there that goes r sub b. Is this showing up there? Should I do that a little bit? Tell me when. Is that good? There's a fine line between seeing where you're at in the room and how about that? Okay, so my issue, I'm going to draw this and then erase this part, is really I need to find that, which is the RA to B. So if I know, okay, again, Alt. Okay, go back to the, I know if I add the RA, then I should get RB. And the reason I'm having to do this is because the goober head that wrote this thing, he actually put this 5 foot and 40 degrees. And so, and you know, he's probably just wanting us to be able to figure out how to find that. So that's the hardest thing I've got to do. So I'm going to haul off and go after RA first. And so RA, I'm assuming from the way he's got these hinges, that these hinges right here are right along the y-axis. I have no evidence outside of the drawing to assume that, but I'm going to assume that. So that pretty much means that my I component, and I'm leaving myself some space. If I had my tablet, I could select it and move these things over, but I can still move, you know, I can still do that here. I've got that. So that draws me out to here. The next thing is I need to be able to draw out to the Z and the X. So if I stood out here and stared right down the Y, this guy would see this. Now give me a second here. He would see, you really don't care. You don't care, I mean, you don't care that it's 5 foot. It has to be 5 foot on both those, or the door won't have a place to close. So all you really care about is that part. So it is true, if the door closed and somebody made the thing so it would have a door jamb and everything, then yeah, that'd be 5 foot. Does it really matter? No, that part doesn't matter, and this part doesn't matter. Oops, but that last part that got erased did. Here. Wait, Alt? Okay. But what does matter is that he tells us that's 40 degrees. So what I'm trying to find is the triangle, not the arc where it closes. Okay, wait a minute. Oh no! Oh. Who in the world is going to call me? Go away. I know who that is. It's the salesman. So the question is, what are these? This is 5 because it's the length here is 5. Cosine 40, but that's running out this direction or out this direction, which is in the x component. There is the x component. 5 cosine 40, and now I can put the plus there. But I also have this thing running upwards. And this part here, maybe I can, this part, I just happen to look out. It's going in the straight up direction or the z direction, and it's 5 sine of 40, 5 sine of 40, and it's the k. So I've got the x component, the y, which that was easy, and then the z. And so he's given us this door. Am I 8 foot is important? Am I 5 foot important? And the 40 degrees, and that's pretty much it. And so at this point, now I'm not looking anymore. Uh-oh. Okay. The next thing to do is find RB. Now, got to stare at it a minute, and you have to kind of make an assumption. He's drawn this vertical line, like right down here, and it disappears behind the door, and he's got a line that goes over here. So I'm going to have to assume, and hopefully correctly assume, that that appears like that bolt is in the ZY plane, this little part here. I really don't, it's kind of this interpretation of the geometry. Past that, I don't, that's all I've got to go on. So I don't have, if it is on that wall, then I have nothing in the x component here. Go back to here. I have nothing in the x component because that thing is sitting flush against the wall. And then usually you write the y component next. I mean, I guess you don't have to, but most everybody traditionally writes the I component, then the J, and then the K, but there's nothing that says you actually have to. And then 12K. So, in fact, I've got this one, and I've got that one. So now I can basically do this. Oh, well, I guess I could erase those. And then I can do that. And then just slide it over here. And for that matter, well, here, I'll tell you what, I'll do this. Slide both these back over. Or I'll put that over. It's that's sort of cheating. Hit the Alt key, hit the eraser, get rid of that, and then come back with this. So that's the case. So if I'm adding RA to RAB, then I just move the RA on the other side, meaning I can just flip the RA over, but, that's, anyway. So now I'm just at the point where I'm going to basically subtract these two. And unfortunately, I have my RA above my R. But then again, why don't I just go to MATLAB? So give me a minute. You got to look at the bottom of the screen when it's going to get its licensing thing. Oh, there we go. So now I'm going to have to kind of use the mouse to see if I can sort of push this thing. I think I could fit both of those on there. Is it that? That's not what I want to do. I want to do that. So I don't know. I'll do R. Doesn't really matter which one I do first. RA is equal to, and let me slide my chair over. What I say first? RA 5 times cosine the degree. Cosine degree, and I'm entering degrees at 40, right? 40 degrees? Yeah. And then, wait a minute. I forgot to put my... So I want to keep them in the components. And then what's the other one? 8, and then 5 times sine degree of 40. Did I do that right? I better look and make sure I type that in right. 5 sine of 40, which should be right here. 8, and then 5 cosine 40. So I think I'm okay. I just get 3 numbers of which I know 8's in the middle, but these other two, I would have never guessed what they would be. RB, that one's a little easier. 0, 5, and 12. Now, if I want to know the vector that goes from A and then ends up at B, I want to, and so what I'll do is list it RAB. And I'll say it's RB minus RA. So there it is. I mean, it's just some numbers. So I guess technically, I don't know why, but I guess I'll make it complete by doing a copy and then write it down here. Say RAB is equal to, and let's see if I can just do like that and do a paste. I know how to do it at the house, but I'm not sure I know how to do it here. This is a different, you know what I'll do? Well, I guess I won't do that. I'll just say minus 3.83i minus 3i plus 8.786k. That was supposed to be a j, by the way, and that's supposed to be a k. Now, he wants to know the length of that chain. Of course, the length of the chain is the norm of RAB, which is usually, it always is written as 3.83 squared plus 3 squared plus 8.78 squared. It's each of the components squared. But luckily in MATLAB, what I call it, picture RAB. So I can just type in norm, oops, RAB. Yes, that's what I meant. No, there's an intelligence in MATLAB. A little bit more than 10 feet, 10.04 feet. I don't know. Oh, I can't. This is not a touch screen. So here. So the length of the vector that goes from A to B. Did I say 10.4 or 04? Wait a minute. Hang on. 10.04. Now, I can go check that. Wasn't that one of the things he asked? That was one of the things, right? No. Well, he just says 10 feet. There's some digits there. Okay, back to my stuff. So, the next thing you've got to do, let's see if I can scroll down. Your goal now is to find a normal, I keep saying normal vector. And sometimes I say base vector, but I should be saying the unit vector in the direction of RAB. So if in the videos I say a normal vector, normal kind of to me, that's supposed to be normal to a surface. I shouldn't say that, but sometimes I'll say a base vector, and sometimes, a base vector is okay, but in the textbook, he calls it a unit vector, which in fact, a base vector and a unit vector, base vectors are always unit vectors. Unit vectors are not necessarily base vectors. So I should be calling it a unit vector. RAB. I take the vector, take the actual vector, not the magnitude. The magnitude goes on the bottom. Here, I'll do this. Okay, what I've written is not correct, but let me fix it. Okay, hello? Okay. There you get rid of that, get rid of that. Okay, so on the top is in fact the vector. On the bottom is the norm of the vector. So luckily, MATLAB helps us there too. What was it called? RAB. The unit vector in the direction of RAB is equal to RAB divided by the norm of RAB. What did I type in? Oh, I had the caps lock on. So, unit vector in RAB. Yeah, so I had the caps lock. Okay, so there's your base vector, not base vector, unit vector. And it's, here I can use the Alt tab to go back and forth. And it's not a touch screen, so I gotta move it out of the way. So the unit vector is minus 0.3814I minus 0.2987J. Was it 87? Yeah. And then 8748. I can't remember. It's a plus. Okay. Oops. Can I move over? And then move back. Then move down. Okay. So, if you want to check, if you feel uneasy, you can look at the norm of that vector. URAB should come up, and it's a unit vector. And so now all I've got to do is if somebody tells me any vector direction, say you have some unit vector, and I know along that unit vector somebody's putting, what are they putting here? It was 50 pounds. So if you put 50 pounds in that direction, then the vector itself is nothing more than 50 times that unit vector. So that's all you're doing. There's nothing fancy here. Here, let me get rid of, that's the wrong thing. Okay, here. Get rid of all this. Get back here. And if you want to find that 50 pounds, oops. All right, here we go. All you do is take the URAB, whoops, and we'll just multiply 50 times it, because I think it was 50 pounds. Yeah, it says 50 right there. And I need to call it something, so I'm going to call F resultant, because I don't know anything else to call it. So this is what I get. I get nothing more than, I can bounce back and forth between these two. The resultant vector, which is nothing more than 50 times URAB, is equal to, okay, hang on. I have to make sure I don't hit the caps locks. Minus 19.007. I'm just, approximating. Minus 14.393. So, sorry. 94. I don't know. J, and then 43.74 K. Did we get that? I don't know. I mean, oh, I have to hit the Alt. Wait a minute. There we go. So is it 19 minus 1443? I don't know. Oh, I can see that right there. 19.1, 14.9, 43.7. And then if you want to find your angles, you already have the unit vector. So you have your unit vector in RAB. That's the direction that the force is going. So you can just do arc cosine, and if you want the answer in degrees, you got to do the D. And then you can do U, R, A, B. And then you get your 112, which is what he's got. 107. It looks like he's throwing these digits away. And 29. And that's pretty much it. So the difficulty in this problem came from the fact that the geometry was thrown at us in an obnoxious kind of way. And that this door handle, we actually had to find, I thought that people wouldn't try to sell me stuff in class, but they sell you stuff all the time. They kind of ruin, I'm surprised that economic development hadn't shut down because of it. Anyway, so that's pretty much it. I mean, the difficulty was the door was open. It was a funny angle, but if you just systematically look at this, and if it becomes difficult, break it down to two vectors, because this will always occur, even in simpler problems. If there's somebody is going to give you the coordinates of both ends somehow. The key is, how do you maneuver them? Well, you can just draw a vector from the origin to the one spot, and then a vector from the origin to the other spot, and subtract them. It's that simple. So if you get something really obnoxious, I mean, I could see where there could be two doors open and different angles and different things, and I mean, I could show you some cases. I mean, imagine if you had something like this here. I mean, I'm just coming up with something that would be kind of obnoxious in a way. So somebody tells you, he does Z above us. This is the way he generally does. He has X coming at us. So if someone were to tell you, okay, here's one spot. So this is point A. So say maybe there's a funny hook there or something. And he tells you that this, I can't do as good as he can, but so let's say he tells you that's, 63 degrees. I'm making stuff up, 51 degrees. And let's be ridiculous. Let's say this is 5 foot. Now, from that junk, you could figure out a vector that went from the origin to A. It's not going to be easy, but you could figure that out. And then if he did something ridiculous, like, okay, he's got another point over here, and I'm just being, okay. Does that look okay? So he's got some other point B over here that say it's a guy standing here pulling. Here's the guy. He's standing here pulling on a cable, which happens to be from there to there. And he tells you, this guy's 6 foot tall, 6 foot from there to there. And this looks like, I don't know, 20 degrees, and that looks like 10 degrees. At first, that looks like a hard problem, until you realize, oh, I can figure out this, and I can figure out this vector, RB. Neither one is nice and tidy, but they can both be done. And then the next thing you do is you say, well, I'm wanting to find the vector that goes this way. The vector that goes from R, goes from A, and it heads down there to B. And then you draw these vectors and say, well, here's RA, and here's RB. So if I look at the vector equation, I add RA to RA to B, and I'll get the vector RB. So you're just doing a vector equation. So you just focus on finding that, and then just subtract them. And you don't have to worry about it. So what you're doing is, instead of all the information coming at you all at once, you're wanting to break it into parts that you can handle. Just a simple part of finding the vector to A, then finding the vector to B, and then subtract them, and then you got that vector, and you can go with it like that. And it's that simple, you know. What happens in the book a lot of times, okay, so see, that's the same problem, it's just different geometry. Okay, well, I won't work that one because that's the same thing. It's 250 millimeters, 150. The door is hanging down. He's got a brick pattern behind it. It's 500 millimeters out the Y. It looks like it's 30 degrees down from the XY plane. That looks like almost the same problem. Okay, this one's a lot easier because you've got 1.75, 1, and 1.5. And then you got 3 meters. So it says, determine the magnitude of the projected components of the force, which he has a force here. He gives you along the cable AB. Aha. So there is this one probably needs to be done. What time is it? Let's see. I'll definitely do this either right now or next time, but is the other one? Oh, it's the same thing. Okay, so let me go ahead and start this one. Unfortunately, I think we could probably get through it. Along cable AB, where's A and B? A and B. Okay, so what this is, let me give you I'll tell you what, let me just tell you in 2D sense what's going on here. Okay, so then we'll come back and do this one next time. So what he's telling you, let's do it in 2 dimensions first. Let's just do a particular problem and say, now I'm going to make it kind of simple. Let's start this way. I got a vector. It's 50 long. It turns out that it's 40 here and 30 here. Now, this is going to sound stupid, but there's a reason I'm kind of trying to do this. Let's say we want to know the vector F is going to be obviously 40I plus 30J. Now, if somebody said, I want to know the vector along the X component, what would you do? Well, you'd just grab the 40, right? But let's say we had another vector that was, say, in this direction. And I'm going to make it up. And let's just make it a vector that, I don't know. So it's a, what do we want to call it? An A vector. We're just going to call it A. And it's going to be, believe it or not, I'm going to make it 30I and 40J. So it's a vector that goes out in this direction, probably goes to about right here. Now, somebody may ask you, what is the component of this vector, of this one, along that vector? So what you do, the first thing you do is you take your A vector and you normalize it. Okay, you unitize it. Let me say it that way. I should keep using the unit vector kind of. So you make a unit vector along A that's going to look like this. Well, in this case, what it's going to be is 3/5 I and 4/5 J. So what I'm doing is I'm taking this vector, its length is 50, it's a 30, so it's 30 over 50, 40 over 50, and that's the vector, right? Now the next thing is, how do you find the vector of this vector that's laying on in that direction? It's something called projection, and let me kind of show it to you like this. Okay. If it sat here in a triangle and was 90 degrees and you knew this angle, you could easily find that. So you'd take the 50. Ooh, that's supposed to be a 50. I don't know what happened there. And then the cosine of that angle, and that gives you this component right here. That's what you're looking for. It just so happens that, believe it or not, and you probably should know this already. Okay, so if you take two vectors and dot them, and of course it turns out that one of them happens to be a unit vector. It turns out that if you take, what did I call that one? Did I call that one F up there? Yeah, I called it F. If I take F and dot it with, what did I call the other one? I called it a U. Oh, it's right there. UA. Then I'm actually doing this times U sub A times the cosine of the angle between them. Well, it turns out the cosine was that theta. And this one happens to be of length 1. Now, you could go through the process of doing that, or you could realize, and this is in one of those vector lectures if you look back. Okay, so if I'm going to dot these two, oh, I guess I already wrote that part, so let's erase this. Well, you know what, maybe I should put it in there. F dotted with UA, in this case, is going to be, okay, I have to scroll up the screen. It was 40 and then 30. 40I plus 30J dotted with a vector that is 3/5 I plus 4/5 J. Now, so what we have is 40 times 3/5 I dotted with I plus 30 times 3/5 I dotted with J plus, okay, so I did the 30, then a 40. Then I got to do the 40 times 4/5 I dotted with the J, and then plus 30 times 4/5 J dotted with the J. What's I dotted with J? You remember that? You got two vectors. You got I and a J. So actually, if you do I dot J, it's the magnitude of I, magnitude of J, and the cosine of the angle between them. Cosine 90. So it just so happens that it's just nothing. It's 0. So there is no projection of I back onto J. So that's 0, and that's 0. So what you end up with is 40 times 3/5. And what's I dot I? Well, if you're looking at the angle between I and I, it's 0. So it turns out that I dot I is just equal to 1. J dot J is equal to 1. So it turns out that the component that's projected back there in this picture, in other words, that 50 times the cosine of whatever that angle was, is just that. Well, you can multiply 40 times 3 divided by 5 and 30 times 4 divided by 5, and you can divide that by 50, and you can take the arc cosine of it. You can find that angle. Does that make sense? So in fact, these projections, these dot products are always thought of as a projection. Think of it like this. You got two vectors. I want to project this one A onto B. So what you do is you make sure you drop a perfect line there to that, so that that's 90 degrees, and that is the projection of A onto B. Now, if you want to project the reverse, B onto A, you have to, I'll change colors. You have to do it slightly different. You have to kind of, okay. That's supposed to be 90 degrees there. So this, and that's supposed to be a straight line. So if you're projecting one vector back on the other, it has to be 90 degrees to the vector you're projecting onto. So just think of it as a projection is like a projector, it's a shadow. You're basically high noon to this vector is right here, shows the shadow. High noon to this vector is the sun sitting right here. That's the sun, by the way, the little red thing with the, I don't know anything else to do, so here, that's the sun. So it produces a shadow on there. And so, in fact, when you look at this, and there is, if you look at this on the, I think I have a video where I covered the dot products, and that's crucial to what, when it says, what is the force along that cable, or along this cable, something like that. Then that means you got to project it onto that cable. So it means you take this vector, and then you take the direction of this vector, this cable you're projecting onto, you dot them, and boom, you got it. It's just that simple. You don't actually have to find the angle, but he does come back in this, and he says, what's the angle? So if you come back, he says, okay, so there he doesn't. But what does he do here? Determine the angle between the cables AB and AC. So we'll do both of those. But that'll give you a preface to that. And actually, if you go back into somewhere, one of these videos, you know what? I may have them out of sync. It might be in week 5. Let me run to week 5. Nobody ever said that I was going to be perfect on my... Uh-oh, it is. There it is. Video 1. Okay, sorry about that. So, out of sync a little bit, but, not terrible. Okay, so we're done. Let's call it good.